After selecting first function and second function, how we apply ILATE method? This is how we want to apply ILATE method. After selecting first function and second function, first function into integral of second. So here we are integrating second function alone. We are keeping first function as itself, minus. In second term, we have a common integral, and inside bracket we are differentiating function and integrating. So now we know how to apply integration by parts. First we want to select a first function and second function. After selecting first function and second function, we want to apply this formula. First function into integral of second function minus integral of derivative of first function into integral of second function. So we can do one example. Evaluate, question will be always like this. Evaluate integral x into e raised to x dx. So here integrand is product of two function, x into e raised to x. So we want to apply integration by parts. So we want to select a first function and second function according to ILATE method. So which is our first function, which is our second function? So ILATE, inverse trigonometry, logarithmic function, arithmetic function. So here x is an arithmetic function, polynomial function. So x is our first function, and trigonometry exponential. Exponential function comes in last position. So e of x, we can select it as second function. Then after selecting first function and second function, we want to apply this formula. So how we can apply? First function into, so here first function is x into integral of second function. What is second function here? E raised to x. So integral of e raised to x dx minus integral of, in bracket, derivative of first function. So d by dx of x, derivative of x into integral of second function. So integral e raised to x dx. So this is how we apply ILATE method, integration by parts. So first into x into integral of second function e raised to x dx minus integral of derivative of first into integral of second dx. Then apply integration. So x, first function we are keeping it as x itself. Integral e raised to x is e raised to x minus integral of, so this integral is common for both these two terms. So first you can solve this bracket. So derivative of x 1 into e raised to x dx. So here we are not, after integrating these two terms, we are not applying integrating constant. Finally we will add one integration constant for all these terms. So that is equal to x into e raised to x minus. So 1 into x, inside bracket we simplified it as 1 into e raised to x. So 1 into e raised to x is e raised to x. Then this term we want to integrate once again. So in second term actually we are integrating two times. First one is inside integral, then another one is outside common integral. So integral of e raised to x is e raised to x plus c. So this c is integrating constant for all these three integrals. So what is integral x into e raised to x dx? That is x into e raised to x minus e raised to x plus c. So this is how we want to apply integration by parts or ILATE method. So first function, second function, after selecting first function and second function, apply this formula, that's all, integrate. So first into integral of second minus integral of derivative of first into integral of second. So one more example, that is evaluate integral x into sin x dx. So here also integrand is product of two functions, that is x into sin x. So here we want to apply isolate method. So which function is first function, which function is second function? According to isolate, inverse trigonometry, logarithmic function, arithmetic function, then trigonometric function. So here arithmetic function x is our first function and second function is our trigonometric function sin x. So after selecting first function and second function, we want to apply this formula. So how we can apply this formula? That is equal to first function into, so x into integral sin x, second function means sin x, so integral sin x dx minus integral of derivative of first, so d by dx of x into integral of second, integral sin x dx. That is equal to x into, apply integral. What is integral sin x? That is minus cos x minus integral of derivative of x. So we want to simplify this bracket first. So derivative of x is 1 into integral sin x is minus cos x dx. Then simplifying this, minus I am taking outside, then minus x into cos x, minus I am taking this minus inside, then sorry, minus I am taking outside, so minus into minus become plus integral cos x dx. 1 into cos x is cos x dx alone. So here we want to apply integration once again. So applying, we get minus x into cos x plus integral cos x is sin x plus c. So answer will be minus x into cos x plus sin x plus c. So this is how we want to simplify isolate method or product rule in the case of integration. So this is the method that we call integration by parts. Next, you try to solve these three questions. So these three questions are same method, integration by parts. So first question is integral x into cos x dx. Second one is integral log x into x dx. Third one is integral 1 plus x into e raised to x dx. So try to solve this three by yourself.